Yeah, good morning everyone. So this will be our last class on science and tech. So this will be a very short class. We will be firstly discussing the concepts, underlying concepts on recent Nobel Prize and other prizes in 2022. Mostly we are covering the Nobel Prizes only. Go ahead. First one is Nobel Prize for Physics. Who all got this prize? Our objective is not to learn this person's name or anything like that. We only focus on what is the underlying technology, how it redefined XYZ sciences and why they are given these Nobel Prizes. So this Alain Aspect, John F. Clauser and Anton Zeilinger, these three persons were awarded Nobel Prize in 2022. They done the experiment in Bell inequalities and quantum information sciences. So this is more details on their. This you can read it out for getting more info. We will focus on what is Bell inequalities. What is Bell inequality? Bell inequality places constraints on correlations between certain physical properties of a system that are separated in space. Understood anything? Remember quantum mechanics class or quantum mechanics discussion? What were the concepts we were discussing then? Superposition. What is superposition? Usually all digital system has bits, 0 and 1 value. Superposition, quantum, the basic unit is qubits. These qubits can take any value between 0 and 1. So it gives infinite possibilities. That is principle of superposition. Second principle is principle of entanglement. What is entanglement? If two photons are entangled. Now these two photons, irrespective of whatever the physical separation they are having, one is in this galaxy, one is in other galaxy, even at this physical separation, if you change the XYZ properties of one photon, then that will instantly reflected in the other photon. That is quantum entanglement. Now these two principles you know. Now what Bell inequality is saying, there are certain constraints. If these constraints, suppose these physical systems are separated in space. Now these constraints are not met. If these constraints are met, then this become a localized system. Localized system means mostly classical laws of classical physics is applicable there. Laws of classical physics is applicable there means then you cannot have quantum entanglement. You cannot, how will you communicate with, suppose two different galaxies are there. One photon is in one galaxy and light years apart, one other photon is there. Now if you change the XYZ properties of one photon, it is instantaneously reflected in other photon. So if you think from classical perspective, what is the maximum speed a particle or energy can travel in classical concept? That is in speed of light. Now if something is separated between galaxies, then billions of years speed of light year apart, then there should be that time gap in reflecting this. So these kind of system we consider as localized systems. If Bell inequalities is met, then that kind of system is localized system that will follow XYZ classical principles. Now how this is applied in quantum physics or quantum sciences? They done some practical experiments and they checked whether Bell inequality constraints are met in quantum science or not. And what they found? These constraints were not followed. That means quantum science is non-local. It is due to quantum science is non-local, then this classical physics applications is not applicable to quantum science. That's why this quantum science can have this quantum entanglement principles. If this inequality were met, if we are coming up tomorrow with a nanotechnology or some other randomly new technology, whether the principles of quantum mechanics, will it apply there also? That how we check this? By applying Bell inequalities. So you get a very broad framework picture on what is Bell inequality, what is meant by quantum mechanics is non-local. Understood? This work was done by these physicists. They done the quantum mechanics and Bell inequality relations, and they found that quantum mechanics is non-local. And these all the principles of quantum mechanics we say today, superposition, entanglement, all these are applicable in this. This was founded by these scientists. That's why they were, for this work, they were given the Nobel Prize in 2022. Totally new words, new concepts. So what question can come is very basic fundamental concepts of this, or what exactly this inequality is related to. Please, you should know it is related to quantum mechanics. Basic idea is this much. Go ahead. Now Nobel Prize for Chemistry in 2022. This was given to these three scientists. We are not reading out their names. All these details, who was given, what was their findings of the research, you can fairly go through this. We'll discuss what is this click chemistry and what is bioorthogonal reactions. Okay. Other details you can pause the video and go through this. Go ahead. This is also a similar file. What exactly is click chemistry? What exactly is click chemistry? Anyone heard of this or remember what you have read in newspapers? Click chemistry is a set of chemical reactions that are highly efficient, selective and yield products with minimum byproducts. Where this is applied is, suppose you have to make drugs. We speak about molecules. We say that NaCl is a molecule. This is like a very poor molecule or very innocent molecule. To Na crystalline structure finish. But if you speak about biomolecules, you speak about drugs, these are very complex polymer-like molecules. So many atoms, so many active particles, so many oxidizer, all these are within the molecules itself. It's a very complex particle. Now this click chemistry is some kind of XYZ chemistry that is associated with production or intermediate processes for production of very complex drug or other kind of molecules. Getting some idea? Objective is to create simple, reliable, modular chemical reactions that can be used to rapidly and efficiently build complex molecules. You need to build this molecule. To build this molecule, you are making some special set of chemical reactions. These reactions in general, we call it as click chemistry. What else? Material, this is application in material science, drug discovery, bioconjugation, all these examples. Now, that is one concept, that is click chemistry. Come to the another very related topic, that is bioorthogonal chemistry. Here also, chemical synthesis that involves use of chemical reactions that are orthogonal or independent to one another. What does that mean? Suppose a very big drug is to be made. We make one reaction for one part of the drug, totally independent reaction to building another part of the drug, totally independent reaction to build another part of the drug. After have all this combined together to form the whole drug structure. That is one part. Then orthogonal means there is one more meaning to it. These reactions are bioorthogonal. That means they refers to they are not found in nature. Nature, these biomolecules may be produced, but that will be producing in totally different ways. This way, this bioorthogonal chemistry is dealing, that is not at all related to the processes that you found in the nature. So this can be possibly a statement. These are not inspired from natural processes. This orthogonal means your natural process is like this, you are approaching the same thing from completely different direction. If nature is making this process like this or molecule in this way, you are approaching this in completely different direction. That's why it is called bioorthogonal chemistry. Got some fair idea what is click chemistry and what is bioorthogonal chemistry? Go ahead. We have Nobel Prize for Medicine 2022. That was given to Suvanto Pabo, founder and director of this. What was his study area? Medicine, obviously. Nobel Prize for medicine that will be given to medicine. What it does is Neanderthal. What is Neanderthal? Early human, if you look at this evolution of human evolution, these are like one kind of species that is found in millions of years ago, or at least more than 1 million years ago. Now, what is speciality of this? What he studied is he got a what? He got some fossil of this XYZ. Now, this fossil is very difficult to conduct DNA study. Why? Because there has been so many losses, there will have been degradation, you will not get correct genome structure, nothing you will get. But he created a methodology for studying the genome structure of even if you get a very old species fossil. Now this branch of science is called paleogenomics. You get a fossil of some XYZ, you are conducting this experiment and trying to get the genomic structure of it. And you are comparing with the human species and finding where exactly is the difference coming between these two. That is exactly he was done. What is Denisovan? This is also early new species. We have found fossils for this also. So all these studies were conducted by for these studies we are given Nobel Prize. These all are like Neanderthal is from European region, Homo sapiens developed from Africa, while Denisovan is somewhere here. You can read the more details of this here. What is difference between mitochondrial DNA and nuclear DNA? This was one major aspect in his study, that's why we are covering it here. Mitochondrial DNA consists of mitochondrial genome. This is like nuclear DNA and DNA. Double stranded, both are double stranded, arranged in a single chromosome. Several chromosomes will be there. 0.25% of DNA is only there in mitochondria, by 99.75% of this DNA is in nucleus of the cell itself. Free floating it is found in a very fixed permanent approach, enclosed by nucleus, not enclosed by envelope. Only this much of bases is there, 3.3 billion bases is there for nuclear DNA. Not tightly packed, very tightly packed. All these are covering in a very similar direction. When if you get a statement, you should be able to identify this. Nuclear DNA means a very structured DNA. That is what DNA is, do the hereditary functions. These are like sideline DNA, consists of 37 genes, 20,000 to 25,000 genes. Non-coding DNA it is called, contains non-coding DNA, lacks non-coding DNA, replicate independently from nDNA. These are replicated only during the phase of cell cycle, special reproduction cycle, inherited equally from both parents. This is very important point. Mitochondrial DNA is inherited only from mother. It's only maternally inherited, while what is this? Nuclear DNA is inherited from both the parents. So, sex of an individual that is determined by mitochondrial or nuclear DNA. So, obviously from nuclear DNA only. So, that's all on this Nobel Prize. Here what all you should focus is only the basic idea of concepts. What is the concept? What it is related to. Like click chemistry, what it is related to. Similarly, the physics Nobel Prize concept, what it is related to, Bell inequality and all. That's all for now, though this will be the end of our whole science and tech sessions. We have through 10 sessions complete all major developments in science and tech from 2022 Jan to recent past. Almost in theme wise, we have covered almost all major developments. If there is something that is left, we can take a miscellaneous class in the end if there is something left, or any new developments has happened in the recent past, or we need to cover this. Otherwise, whole this science and tech is well wrapped up. What is pending? We have done the science and tech PYQs also. So during that also our focus was on we are focusing more on those questions that can come in future, and there was more talks on these basics of every question which we are discussing. So if you are watching online, you go through those PYQs discussion plus these 10 sessions that fairly covers everything that is required for science and tech. And these all PPTs, I will compile it and post it in the group or upload in the portal. You can download it from there. It will be around 200 slides for current affairs. You can fairly revise it. It will be mobile friendly. You can revise it there itself. Next, our next point of interest is we'll start with economy sessions. Dates I will let you know. Next, we are starting with economy, current affairs. Same format we will follow, theme wise. We will compile whatever developments like fiscal policy, monetary policy, what XYZ development is, forex reserve. Theme wise, we will divide the economy and do whatever the compilation of all the developments that is happening in the recent past. That's all for now. Thank you so much.